Want to learn examples like this with me? Keep watching to learn how. Now that we have discussed and introduced that I have introduced you to the concept of ions, okay, so let's have consider an example on ions. So the question that is the fourth question in our section is basically saying how are ions basically formed. Now the answer to that, and before getting on to the answer, what I want you to recall, okay, if you could remember from our discussion, we said ions are basically formed when you either add or remove electron from an atom. Now basically what you have is an atom structure, which we talked about in the first example. Now what you do is either add the electron or remove the electron from that atom, and basically when you do that, ion is formed. Okay, so let's go ahead and write what we said in a complete sentence. So what we said is basically ions are formed either by what we said adding, and I'm quoting that because it's important, by adding or removing electrons from what we know is atom. Now we have our fifth question up on the whiteboard, and it says an atom with 6 electrons. I need you to focus on. So let me go ahead and grab a marker to highlight something. You have 6 electrons, 6 neutrons, and 6 protons. Now what would be the net, sorry for the thing over here because I basically messed up. So what would be the net charge of the atom? What would it be? Now we introduced that the net word basically comes from Isaac Newton, because he said the net force of something, what we learned in fundamental physics, basically that's a different topic which you can go ahead and check out from my playlist, but basically what it's trying to tell us is that 6 electrons, 6 neutron, and 6 proton is basically what is the main idea of this question. Now when you have that, let's go ahead and draw the example on, or what we call a model. So if you have the model over here, you basically have 1 electron, let's try it. 2 electron, count with me. 3 electron, 4 electron, 5 electron, 6 electron. Basically we are qualifying with our question here, and let's go ahead and draw the protons. Now the protons I will draw in the red marker. Proton, 1, 2 proton, 3 proton, 1 proton, 2 proton, 3 proton. Now what's left is basically the neutrons, right? But before going on to that, these new electrons are basically orbiting the nucleus, and we now know that the nucleus is consisting of protons and electrons. So let's go ahead and draw the electrons. So you have neutron here, that's 3, count with me, stay focused, 4, 5, and our last one, 5th. Now if you guys can see the structure of the atom properly, you'll figure out sooner or later if your idea blinks, or if you're smart enough, and if you can add or subtract, you can basically say that if you have 6 electrons, that is 6 negative 6 number. Now since electron is negative, the sign of it is negative, and the neutron is basically neutral, so we don't even need to care about that. So, and 6 protons, which is positive, and it's 6 over here and 6 over here. So basically you have 6 negative signs and 6 positive signs. Now what happens is positive and negative cancels out. Remainder is basically 0. So the answer to that would be 0. Now let me write it in black color, since the answer would be in black. Now the answer to that would be 0 net, that is charge. Now the 7th question is up on the screen, and it basically says that gravitational and electric force are similar in each of the following ways, except. Now recall that we said that gravitational force is similar. The equation, as you guys can say, that we just did a moment ago is basically similar to the one equation that we did in fundamental physics, which is a gravitational force that was invented or discovered, as you guys can say, by Isaac Newton. Now we need to know what is different about this equation, or what's different about the following ways, except what the similarities is. Now let's go ahead and review the similarities in order to find the different things. Now the first similarities between the gravitational force, so let me just highlight it. Gravitational force and electric force is basically the force acts over some distance. So the forces in gravitational force and this electric force here acts over some distance. Okay, now both over here involve some inverse square relationship that we taught in static electricity, so I don't want to go into it. Now the third thing, okay, is basically both causes some acceleration to an object. Now what's remaining? This is the main part over here. You need to think, or recall, as you guys can say. It's basically that this force over here can only attract, while this force over here can attract or repel. Now the answer to that is just what we say is the relationship of attraction and repulsion. Repulsion and attraction. Our sixth question is up on the screen, and it's basically saying two objects of equal charge are separated by 0.0029 meter, and notice that I have highlighted that and experience an electric force of 0.98 Newton. What is the charge of each object? Now recall the formulas that we discussed in static electricity. Now the formula to solve this is basically easy, but what I want you guys to know is basically the steps. You need to follow the steps that we did in the section. Now I already know how to do this, but let's go ahead and follow the steps. Now what's given is basically I have less room, so you need to, in your piece of paper, if you're doing on the piece of paper, what I want you to do is write the distance, which is 0.029, that is meters, so we don't need to convert that, and the electric force. Now it's force, and in the fundamental physics we say that if there's something related to force, that is Isaac Newton that he created, so it has to be Newton. So Isaac Newton at his last initial N, so 0.98 N, which basically is the SI unit that we use in physics. So everything you can see is in SI units, so you don't need to convert that. We have successfully completed 2 steps. Okay, now what we need to do is think of the equation. That is our third step. Now when we think of the equation, recall that the equation that we use is basically the electric force that we write it as the force, that is electric. Okay, I'm just gonna write ELEC, okay, times the K, which is the constant, times the charge 1 times the charge 2. Okay, basically Q represents the charge, okay, divided by bracket the distance that is squared. Now recall that what we are given is the electric charge, okay, electric force, and the distance. We are not given none of this. Now in our section of static electricity, we taught that the K is constant, and because it's constant, okay, K over here is constant, and because it's constant, it has a same value that you will write it for each and every problem that you might need to use this. Now the value for K, I'm just gonna tell you, okay, is 9.0 times 10 raised to 9th, okay, and let me just put this units over here in the equation and basically solve for the answer. So basically when you solve for the electric force, okay, you need to solve for the charges of these two quantities over here. So the electric force we have is 0.98 newtons is equal to the K, which is, I'm just gonna shift it right here, so 9.0. Now you don't write times 10 to 9 power, you can basically write E and basically write 9 times the quantity 1 that we don't know times the quantity 2. Now if you have two quantities that represents the same charge, what can happen is basically cut these things off, basically write 2Q, okay, two quantities, and you divide it by the distance, which is said to be 0.029 meters. So 0.0029, that is being squared. Okay, now let me just shift the camera and it makes some noise. I'm sorry, but I have to do this. So you guys can see that we have put the values into our equations, right? All we need to do is use a calculator, such as I did in my T89. I can find my T89 right now, but there's more calculators that you'll see. But okay, now when you put this in your calculator, you get your answer, and let's write the answer. Let's be practical over here, and the answer that you get, okay, answer that you get is basically 3.0 E negative 8. And remember, you need to remember our last step, which basically states that you need to write the unit, and when you have the unit, write C, which if you don't know, please check out my official static electricity. So, okay, so the answer would be this one. Now, if you don't understand the concept of E, it's basically saying 3.0 times 10 raised to negative 8, that is C. That is the charge of each object. That brings us to our 8th question, which basically talks about the mid-core section of what we talked about in static electricity. Now the 8th question basically says a material that doesn't allow the electrons to flow easily is called what? Now let's talk about the material that basically allows the electrons to flow easily. Now we talked about two different things that basically, actually three different things that basically allows it. Now that is conductors, semiconductors, superconductors. But when a question pops up to you that a material that allows electron to flow easily is called what? Now the answer to that question is basically one answer, and what the answer is basically conductor. Okay, but the question here is asking us what doesn't allow, what material doesn't allow the electrons to flow easily in their pathway, kind of follow those rhythms right there. Now the answer to that would be some kind of insulator, right? Because conductors allow them, and the opposite of conductor is basic insulator, which prevents them to flow easily, you can say. So the answer to that would be, let's keep our particular mind, write the answer with black. So the answer to that would be insulators. Okay? That would bring us to our next question, which is 9th question. That will appear on the screen just a second.